Control is how you protect hard-won improvements. Sustainability matters because gains fade without daily discipline. Teams change, demand shifts, and processes drift. A stable process reduces waste, defects, and rework. It improves safety, delivery, cost, and morale. It also supports environmental goals by cutting energy, scrap, and emissions. Control makes results predictable, so promises become reliable. The aim is not perfection. The aim is a process that stays capable under normal stress. That is the heart of continuous improvement. Pick measures that show health and outcomes. A key performance indicator, KPI, is a critical measure of performance. Lagging indicators show what happened, like monthly defects. Leading indicators predict, like setup compliance. Good systems use both. Examples include cycle time, on-time delivery, first-pass yield, and rework hours. Add environmental measures, like energy per unit and scrap rate. Balance customer, cost, quality, safety, and sustainability. Keep definitions clear and simple. Make the data easy to collect daily. Every process varies. Common causes are normal fluctuations inside the system. Special causes are unusual events from outside. Treat them differently. Do not redesign the system for a single odd spike. Do not ignore patterns that show the system is drifting. Teach teams to ask what changed. Trace sources like materials, methods, machines, and people. Stable processes are predictable within a band. Unstable processes surprise you often. Control charts help you see the difference. Control charts are a statistical process control (SPC) tool. SPC monitors variation over time. A control chart shows a center line and control limits. The center line is the process average. The limits show expected variation under common causes. Data points outside limits suggest special causes. Control limits are not specification limits. Specification limits reflect customer needs. Control limits reflect process behavior. When the chart is stable, you can predict future performance. When it is unstable, investigate and act. Pick the chart that fits your data type and sample size. For continuous data with single readings, use an individuals and moving range chart. For continuous data with subgroups, use an X-bar and range chart. For attribute data with pass or fail outcomes, use a P-chart. For attribute data with defect counts per unit, use a C-chart. Start simple and build skill. Keep sampling consistent so the chart reflects real changes, not measurement noise. Use standard rules to detect special causes. Any point outside a control limit is a signal. 6 or more points trending up or down is a signal. 8 or more points on one side of the center line is a signal. Sudden jumps in range or spread are signals. A pattern that repeats with a cycle suggests a hidden factor. When you see a signal, pause and investigate, document the cause, and adjust your plan. Imagine daily order lead time in hours. You record one value per day for a month. Build an individuals and moving range chart. You see most points near 24 hours. One point hits 40 hours. That point is outside the upper control limit. The team checks the day. A system outage delayed printing labels. You fix the outage root cause. Future points return inside the limits. The process is stable again and predictable for customers. A control plan is a one-page map of how you will hold the gains. It links each key characteristic to its measurement, limits, owner, and reaction. It prevents drift by clarifying who watches what, when, and how. It captures the method, frequency, and tools. It also defines the response when results slip. Include quality, delivery, cost, safety, and environmental aspects. Keep it visible to everyone. Review it when changes occur or risks increase. Use this simple structure to build your control plan. Process step, packing station. Characteristic, order lead time door to door. Specification, target 24 hours, maximum 36 hours. Measurement, method, timestamp from system, daily at 5 p.m. Control method, individuals and moving range chart on team board. Sampling frequency, daily. Owner, shift supervisor. Reaction plan. If outside control limit, stop and investigate. Escalate to manager if not fixed in 24 hours. Verification. Leader audits twice per week. Make status visible at a glance. Post the control plan at the workplace near the process. Use a simple dashboard with green, yellow, and red thresholds. Show the control chart, updated daily with today's point highlighted. Use and signal lights to flag stoppages immediately. Display standard work and checklists at eye level. Label gauges and probes with the method and frequency. Keep boards clean, current, and owned by the team. Define routines that lock in control. Daily, owners plot data, check limits, and note any signals. Daily, the team reviews the board in a stand-up 5 minutes. Weekly, the leader verifies data quality and reactions were done. Monthly, the process owner trends KPIs and reviews risks. If a signal appears, trigger the reaction plan without delay. If 2 days show no fix, escalate to the next level. Capture learnings and update the control plan. Control charts reveal variation, while control plans drive action. Visual management keeps everyone aligned and engaged. Sustainability grows when owners follow simple routines. Watch leading and lagging indicators, including environmental impacts. Respond to signals quickly and verify the fix. Keep improving the system and your gains will last.